So the big picture for this lesson is logarithms. So what is a logarithm? Well, a logarithm is a function that's used to solve the problem, how do you write an inverse of an exponential function? So for example, an inverse of a linear function is also linear. Inverse of a quadratic function is a square root function. Exponential growth, that inverse is a little tricky because you can't just say y equals 2 to the x. And then typically what you do to solve for an inverse is you switch the x and the y and then solve for y. So you get x equals 2 to the y. But then how do you solve for the exponent? There's no mathematical step here for this. So then the problem is, how do you represent the inverse of exponential functions? So a new function called logarithms had to be developed. And a logarithm is used to represent the inverse of exponential. So it looks like this. If you're going to do the inverse of f of x equals 2 to the x, it would be f of x equals log base 2 of x. And so the base 2 is the same as this base 2 for the exponent over here. And the exponent y, this is y equals f of x. So this f of x here is the exponent. And then the x over here, this is what 2 to the y is equal to. That goes right here. So the way you read this, once again, is f of x equals log base 2 of x. So what does the graph look like? Well, since it's an inverse of exponential growth, it reflects through the line y equals x. Okay, so it looks something like that. So this is y equals 2 to the x, and this is y equals log base 2 of x. And there are also some rules with special bases, like most calculators you can do different log calculations, but only with two bases. You can do log of x, which is log base 10 of x, called the common log. And also you can do this other logarithm written this way. This is natural log. And this is log base e. And it's called natural log because base e is, in exponential functions, called the natural growth factor. So common log is base 10, natural log is base e. So that's the big picture about logarithms.